In section 4.10, we're going to talk about balancing oxidation-reduction equations, and this is a lot more difficult than balancing normal equations from regular chemistry. There are very set steps that have to be followed, and as you'll see in a moment, these steps are very intricate, and you need to just practice this and do several of these over and over again until you get the pattern down. The first step is to realize really that these things are aqueous. They're in water. There's water moving all around the ions and the solids that are present, and that water might actually interact with the reaction. And so we are going to be pulling water in and out of reactions to see if that helps balance the equation. But firstly, we're going to separate the equations into two halves, the oxidation half and the reduction half. So this copper was solid, which means its oxidation number is 0, and now the copper is a +2, so it's lost 2 electrons. So I separated these out as the oxidation equation. Then here's the reduction equation. The nitrogen is changing its charge from the reactants to the product side. It's gaining electrons. So there's the reduction equation. Then here we go. Let's balance each half of the reaction. We'll start with the copper first. That one will be a lot easier. Step 1 in this part. Balance all the elements except hydrogen and oxygen. Well, we have one copper and we have one copper. So that step was very easy. B. Balance all the oxygens using water. There are no oxygens on either side, so we're not going to bring a water in to balance out the the oxygens. And then C, we don't have to balance the hydrogens on this one because there are no waters being pulled into this half of the equation. That part's also easy. Now D, though, balance the charge using electrons. This part we do need to do. On this side, we have copper, and copper has 29 electrons. Here we have copper +2, which means it's lost 2 electrons. So we need to add 2 electrons to the product side so that the copper ion plus this 2 electrons it's lost are equal to the copper electrons that we started with. These aren't attached to each other, they're just on the same side of the reaction, because these electrons have been given off. Alright, so we balanced A, B, C, and D for copper. Now we're going to do A, B, C, and D for the nitric acid. Again, the first step is balance all the elements except for hydrogen and oxygen. Well, there's one nitrogen here, and there's one nitrogen here. So that part was pretty easy again. Part B, balance oxygen using water. So here we have 3 oxygens. Here we have 1 oxygen. So we're going to add 2 water molecules. That would be 1 oxygen plus the 2 oxygens in this water would equal the 3 oxygens on the left. And then part C, balance out those hydrogens using H+ ions, or hydrogen ions. So here we go. We have 2 times 2. We have 4 hydrogens here, but this is only 1 hydrogen on the left side. So I'm going to bring in 3 more acidic hydrogens, or 3 more H+. And now we have to deal with the charges. We need the electrons to balance out. This NO has no charge, plus water with no charge, so 0 plus 0 is still 0. But on this side, we have a 0 charge for nitric acid and 3 positive hydrogens. If we were to add 3 electrons, we'd have 3 negatives plus 3 positives. That would be 0, plus 0, is equal to 0 plus 0. Now all those charges are balanced out by adding 3 electrons. Now, the next step is to think about how we're going to combine them together. And we have to combine these two equations back together. But the only way we can do that is by multiplying the half reactions so that we get an equal amount of electrons. So how are we going to multiply these 3 electrons and the rest of the reaction so that it equals this reaction with its 2? That's right, we're going to multiply this reaction by 2 and this reaction by 3. 3 times 2 would give us 6 electrons. Now that's also 2 of this, 6 of hydrogens, 2 and 4. And then for the oxidation equation, it would be 3 coppers, 3 copper ions, and 6 hydrogens. And when we combine it all back together, we've got this. We've got 2, we multiplied this by 2, nitric acids, 2 times 3 for the 6 hydrogens, and then there were 3 coppers, 3 times the copper. And on the product side, the same thing. We had 2 waters, so we multiplied that by 2 to fix the electrons. We have 4 waters. 2 NOs times 2, yeah, so that's where we got our 2 NOs. And then we multiplied the copper ion by 3, so now we have 3 copper ions. The reason we're doing this is to get those electrons all in line and make sure we have 6 electrons being taken in and 6 electrons being given off. But when it gets combined back together, the 6 electrons produce 6 electrons and they disappear. Because really the electrons are leaving the copper and going into the nitrogen in the nitric acid, and that's what's breaking the nitric acid apart. And this entire equation is now balanced. 6 hydrogens plus 2 hydrogens is the same as 8. 3 coppers, 2 nitrogens, 2 nitrogens, 6 oxygens, 2 oxygens plus 4 oxygens is 6 oxygens. Everything's taken care of in this equation. So again, we split them apart. We balanced the elements, then we balanced oxygen using water, we balanced the hydrogens, we took care of the electrons. Then we did it to the other half of the reaction. Then we multiplied both reactions to equal out the electrons. Then we added it back together and we made sure it was balanced. I think we're going to take a look at another example now. So here's our next example. We have dichromate reacting with nitrogen monoxide to make chromium and nitrate. And we're going to first split this apart into the 2 equations. So the first equation would be the chromate becoming chromium, and the other equation would be the nitrogen monoxide becoming nitrate. So here we go. They've been split apart. Then the second step is to balance all the elements except for oxygen. Since there were 2 chromiums, I put a 2 in front of the chromium. There was 1 nitrogen, still only 1 nitrogen. Part B, balance oxygen using water. So here we have 7 oxygens. How many waters do we need to add over here to balance them? Well, if it's 7 oxygens, we need to add 7 waters. In the second reaction, we have 1 oxygen and 3 oxygens. Well, we need to add water onto this side to balance the oxygens. So I'm going to add 2 waters. So it'd be 2 oxygens plus that one is equal to the 3 on the product side. Part C here, balance hydrogen using H+. This is 7 times 4, or 14 hydrogens being added in. And then this one is 2 times 2. So on the product side, we're going to add 4 hydrogens. And then we need to, part D, balance the charge using electrons. So here we have a -2 charge plus positive 14. Negative 2 plus positive 14. So that's negative 2 for the dichromate and positive 14 for the hydrogens. That's a combined charge of positive 12. But on the product side, we have the 2 chromiums, each with a positive 3, 2 times plus 3, and then 7 waters, and each water is a 0, so that's just plus 0. So we have a positive 6 charge. We need to add electrons to one of these sides to get the charges equal. Now, if we add electrons on this side, it'll slowly bring this positive 12 down. How many electrons should we add to get it to equal the other side? The answer is 6 electrons.